Good evening, everyone. Welcome to Unacademy, India's largest online learning platform, which is helping the students of all walks of life uh, from all kinds of sectors. I mean to say, you take engineering, you take medicine, you take normal degree students. For everybody, that is helping a lot. Good evening, Satish. Good evening, Harika. Good evening. Good evening. Welcome. So today is going to be the lecture number 8 on electronic devices and circuits, semiconductor physics, part 8. Okay. So hope you are enjoying the classes. If you have any doubts, please post them in the comment box. Right. So far, if you have a very comfortable classes, please forward it to other students. Okay. Hope you don't have any doubts. Hope you don't have any doubts so far. If you get any simple doubt, even if you get a small doubt, also you can post them, or you can ask me in the class while the class is going on. Okay. So myself, Shravan Kumar, I have master's degree from JNTUH in VLSI system design, and I have 10 plus years of teaching experience. I can handle subjects like electronic devices and circuits, analog electronics, digital electronics, and then EMFT. So I have a special code for all you guys, that is SVS10. So which will give you 10% discount on Unacademy Plus subscription. Unacademy Plus subscription. And if we have Plus subscription, Plus subscription will give you access to the live classes. You can attend all the crash courses. You can write the weekly test. This weekly test will play a major role. This weekly test play a major role in achieving your goals, sir. So please do attend this weekly test. And you will be having a doubt solving sessions. So every 4th hour is going to be a doubt solving session, which will help you a lot. Sessions will be in English and Hindi. Those who don't understand English, they can listen to Hindi. Okay. And we have something called Raviteja, good evening. Raviteja, good evening. And we have something called rank improvement batch. So these are the benefits of Plus subscription. And along with that, we have something called Iconic subscription. Now, the extra benefits of Iconic subscription is going to be, you will be given a personal coach, you will be having a study planner, you will be given a study boost sessions, and a personalized test analysis will be conducted of writing every examination, and you will be having a preparatory study material. We have Plus subscription for 12 months is going to be 27,225 rupees. The Plus subscription for 18 months is going to be 34,650 rupees. For Plus subscription for 24 months is going to be 39,600 rupees after using the code SVS10. GATE Iconic subscription for 12 months is going to be 45,225 rupees. This is SVS10 code. After using that, 24 months is going to be SVS10. Use SVS10 to get 10% discount, and then you will get amount of 66,600 rupees. 66,600 rupees is the fees. Okay. Then how to download? How to do it, sir? Simply go to the Play Store, download Unacademy app, install it, and then select your goal, that is as a GATE and ESE, and click on Plus subscription. Then you will be asked to click on Get subscription. Once you click on Get subscription, you will be asked to choose how many number of months subscription you want, and then here you can type your code SVS10 and click on Apply. Then amount will be displayed, and click on Proceed payment, and then you will be taken to debit card, credit card, EMI, UPI, wallet, and net banking facilities. You can use any one of them. Okay. And coming back to this interesting one, so this is going to be a scholarship test. This is going to be a scholarship test, Unacademy combat test. So which will give you almost 85 lakhs of scholarships, 85 lakhs of scholarship for the month of February. And we will be having a GATE combat on 28th of February. This is also useful for the ESE students also. So on 28th of February at 11 a.m. it will be having. So to enroll yourself, click use the code SVS10. Okay. and this is going to be for 60 minutes. The students of ECE and EEE can participate in this. The first three students will give you 100%, for them 100% scholarship plus subscription will be given, and you can use the code SVS10, sir. Again, I am telling you, use the code SVS10 to subscribe yourself. And these are terms and conditions which we have discussed already earlier. For rank 1 to 3, will be given 100% subscription fee off. For rank 4 to 10, 75% off, and rank 11 to 50, it is 50% off, and for rank 51 to 100, 25% off. So remember, all these are for the students of new batches only, not for the previous students who are having. So these are the very important, sir. So you can utilize this opportunity to get plus subscription, This is all about plus subscription only. Okay. Yeah. Yes. Coming to today's discussion, we'll be discussing about mobility of charge carriers. So as usual, we'll cover what we discussed in the previous class in 2 minutes, and we'll come back to it because this is very important to discuss what we have discussed in the previous class. I think we have started with the semiconductor. We have started our discussion with the semiconductor, and you guys know what is semiconductor also. And we have discussed this very important thing, sir. How semiconductor varies its temperature also. The energy gap of semiconductor varies. Any material whose conductivity lies between insulator and metal is called semiconductor. Generally, the energy gap is going to be 1 electron volt. And that energy gap at the 0 degrees Kelvin for germanium is going to be 0.785 electron volts, and then for silicon it's going to be 1.21 electron volts. Okay, and this energy gap varies with respect to temperature. If you increase the temperature to 300 degrees Kelvin, so it will become 1.1 electron volts, and this will become 0.72 electron volts, right? So if you look at here, how it is changes, sir, it is the energy gap of silicon varies with respect to temperature, that is 1.21 minus 3.6 in 10 to the power of minus 4 into T, and then here also it is going to be 0.785 minus 2.3 10 to the power of minus 4 T. Okay, electron volts. And we have seen the beautiful orbital model of silicon atom. Hope you guys understood this is very clearly. So we have discussed what is a nucleus. Then we have seen what is a core orbit. And then we have seen the inner orbits, then valency orbit, and then first excitation orbit. First excitation orbit also we have discussed. So these are the things which we have discussed in yesterday's class. Okay. I think we have also discussed about types of semiconductors. There are two types of semiconductors: intrinsic semiconductor and extrinsic semiconductor. Intrinsic means the pure form of semiconductor is called intrinsic semiconductor, and impure means you are adding some extra. You are adding some other pentavalent or trivalent impurities to it. Then we call it as the extrinsic semiconductor. As I told you, extrinsic means externally something is added. Remember, so how to differentiate it? If you don't, if you have any confusion, remember when somebody says extrinsic, remember that some external thing is added to it. So because of that, we call it as an extrinsic semiconductor material, which will be having of two types, that is N type and P type. We will discuss about this. Don't worry in detail, sir. Sir, remember, we may be going very slowly. But I always believe that slow and steady wins the race. Okay. If I can cover our entire syllabus in 30 hours also, but I don't want to cover it in 30 hours. I want you to understand it. When somebody says, sir, for the first time I am able to understand all this concept, I am feeling very happy, sir. Like yesterday, some Satish was saying, sir, I understood this for the first time, why it is called pentavalent or something he was saying. So I felt very happy. That gives me a lot of strength. Okay. So, I can put lot of efforts, more effort I can put if I can get that kind of feedback. Right. So that is the reason why I am going very slowly. So don't think that I'm doing it soon. So we will complete it as early as possible. Okay. And then we have discussed about the transport phenomena in semiconductors. The current in a metal is because of only electrons, but whereas in semiconductor, the current is because of both electrons and holes. Both electrons and holes. Okay. And we have two types of transport of charges. That is, one is because of the electric field, the other one is because of the concentration gradient. So as I told you example, so the drift current is nothing but whenever generally when you stand outside the classroom and the faculty comes to your class, what will happen, sir? All the students will get into the classroom. Means you are some external, because of some external person, all the students are entering into the classroom. So the movement of the charge carriers is nothing but a current. And this current is because of the external force or external voltage or external field. So that is called a drift current. And then if this is because of the non-uniform concentration gradient, if it is because of the non-uniform concentration gradient, as I told you, so how can you say this, sir? In a classroom, if one side of the benches are completely filled, what will happen, sir? You'll slowly move towards you'll slowly move towards the other end of the classroom where there is an empty benches, right? So that is nothing but diffusion. So very simple concept, sir. Very simple concept, right? So drift and diffusion. Drift is nothing but external force. Diffusion is nothing but internally, because of the non-uniform concentration gradient. This will happen because of non-uniform concentration gradient. This will happen. I think this is what we have discussed, and we are supposed to discuss mobility of charge carriers. Now we will start discussion about the mobility of charge carriers. So what do you mean by mobility? What do you mean by mobility of charge carriers? So very importantly, you guys should remember one thing. See, what happens is, in any given atom, the electrons will be continuously moving. Right? They will not sit properly. They will not sit properly, sir. Always, because the electron has to travel. Electron has to travel. Electron has to. I'm talking about the free electron. Right? So now what happens, sir? The electron is moving from one place to other place. Let's consider something like this. Let's consider you have some positive ions, and then I'll tell you. Let's say some free electrons are available here. I'll talk about this in detail now. Just look at here. Let's say you have one electron here, one electron here, one electron here, and one more electron here, or one electron here. Like this, you have electrons. You have these many number of electrons. Now the electrons will obviously, will electrons sit properly, sir? If the faculty is not there in the classroom, will the student sit properly silently? No, right? So the electron is also same like you. It will not sit silently. It will not sit properly. It will keep moving. So the electron may move from this side to this side and hit the ion, and then it can change its direction. It can hit it again. It can change direction. It can hit it again. It can change direction. It can hit it again. It can change direction. It can hit it again. It can change direction. It can hit it again. It can change direction. So it may continue. Hit it here. Again, it is changing the direction. Hit it here, and it can change direction. Hit it here. It can change direction. See, please try to understand what I'm trying to explain. Sir. The electron in any given atom, in any crystal, will not sit silently, sir. The free electrons, and these are the ions. These are the bond ions. I'll let you know why a positive ion is called positive ion, why a negative ion is called negative ion. Don't worry. I'm here to explain you that. But remember, electron in any given crystal will not be sit silently. It will be moving from one place to other place. And meanwhile, what happens is, it will collide with the ions. So now for in a given in a given in a given atom or in a given crystal, okay, the motion of see, whenever one electron is moving in this direction, obviously the other electron will be moving in the opposite direction, right? So now one electron is moving in this direction, the other electron is moving in this direction. This is a completely random motion is happening. The random motion is happening. Okay, when the random motion is happening, and it is continuous always, right? So, but it is hitting the ions. The collision is happening with ions, and it is changing its direction, right? So, the distance between two collisions, is called generally, the distance between two collisions is called mean path. It's called mean path. Is called mean path. So this can be a mean path, this can be a mean path, this can be a mean path. There are many mean paths for a given electron, right? And when it is and now as it is random in nature, the average value. See, when one electron is going in direction, the other electron is coming in the other direction. So overall, what happens is the total motion of the charge carrier of the electrons will become zero. So because of that, the average current will become zero. What is the current, sir? Current is nothing but what is current? The motion of electron, right? The flow of the flow of electron is nothing but a current, right? What do you mean by current? Current I is equal to flow of charge carriers or flow of current. Flow of electrons is nothing but a current, right? So, but now what's happening here is the electrons are the electrons are not sitting properly, but they are moving. But all the electrons are moving. So one collide with other one will collide with other. So overall, what happens is the average current is zero. Overall average current is zero, right? Overall average current is zero. Average current is going to be zero. But now what I try to do is I try to apply some external voltage. I'll apply some external electric field, and I'll try to apply some external electric field. Now what happens, sir? Earlier the electrons, the charge carrier is moving in the under direction. So this is moving in this direction, this is moving in this direction, this is moving in this direction. So in whichever direction it is moving, sir, right? So in this region I am not applied any electric field, any electric field. Understand this, very important. Electric field. Now what I am trying to do is here now I try to apply an electric field. If I apply electric field, after applying electric field, what happens, sir? All electrons will flow in only one direction. It is just like let's say if you are sitting in the classroom, if the faculty is not there, what will happen, sir? The students will go in different direction. They will sit in different direction. But when the faculty comes, now what happens, sir? All these will flow in only one direction. All the students will look it in the one direction only, right? Yes or no? Arya, tell me yes or no. You are simply silent from long time. Just you said good evening. I am just shouting like anything. Are listening or not? How do I know? Harika, understand? Did you understand? Satish, yes. Meanwhile, you should say something here. Otherwise, how do I know that you are listening? Okay, Satish, Harika, and Raviteja, thank you for reply. See now when you apply some electric field, what happens, sir? All these electrons will flow in only one direction, and they will gain some velocity. And let's say you are applying an electric field of E. You applied an electric field of E. Assume that this electric field E is applied, right? The voltage V, the voltage V, which is the velocity. I will call this as a drift velocity. This is drift velocity. Just a second. See now slowly when you are applying an electric field now, and all these charge carriers are flowing in one direction. All the charge carriers are flowing in one direction. Now what happens, sir? There exists something called drift velocity. Drift velocity. Why is it called drift velocity, sir? Can somebody tell me why it is called drift velocity? I would have called it a diffusion velocity. Why it is called drift velocity? Because drift is a word which is used for electric field. External electric field. Okay. So external electric field, because of that, it is called drift velocity V. Drift velocity V. And this drift velocity V is directly proportional to the applied electric field. Applied electric field. Remember this. This drift velocity is directly proportional to the applied electric field. Now whenever this, you can see here, this is what the velocity, the drift velocity is directly proportional to the drift velocity directly proportional to the applied electric field. Applied electric field. Applied electric field. And there should be some constant of proportionality, yes or no? There should be some constant of proportionality, yes or no? So that constant of proportionality is nothing but a mobility. That constant of proportionality is nothing but a mobility. That constant of proportionality is nothing but a mobility mu. That constant of proportionality is nothing but mobility mu. Right? So what are the units of mobility mu, sir? Mu is going to be meter square per volt second. The units of mobility is going to be meter square per volt second. Meter square per volt second. Hope you got understand what is mobility now. Now the constant of proportionality. The constant of proportionality is nothing but mobility of this charge carriers. Mobility of the charge carriers V is equal to mu into E. Mu into E. Or you can write this is E. If we call it E, or you can write this as E also. No problem. Whichever you want, you can write. Whichever you want, you can write. This also you can say the same thing. Both of them are same. Both of them are same. But if you want to write E capital E, you can write capital E also, sir. So, but remember, this is going to be the mu. The constant of proportionality is nothing but a mu. The constant of proportionality is nothing but a mu. Okay. So units are going to be meter square per volt second. Meter square per volt second. Meter square per volt second. Good, 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 Satish. Good, Satish. Next we call something called current density. Current density. So generally current density is represented with J. Sir, this is very simple, sir. Many students will have a doubt about this. Many students will have doubt about this, sir. So if you know what do you mean by population density, if you know what do you mean by population density, you can understand current density also. So what do you mean by population density, sir? What do you mean by population density? What do you mean by population density? Right? Population density. Population density. Let's consider some city like Mumbai. Let's consider some city called Mumbai. So what happens, sir? Is the number of people who are living in the city, the number of people who are living in the city is nothing but population density. So what do you mean by population density? Number of people living. Number of people living. Number of people living in this area by its its area. Simple, yes or no? What is population density? What is population density of Mumbai? It says just the population density of Mumbai is very high. The population density of Bangalore is very high, or the population density of Delhi is very high. So what do you mean by that, sir? In a small area, more number of people are living. In a small area, more number of people are living. Right? If you go to villages, the population density will be less. If you go to villages, the population density will be less. Okay, did you understand this point very clearly, yes or no? So I think you understand this concept called population density. Similarly, apply same thing here, current density. Current density, what is current density? Current density, name itself says, whenever somebody says density, remember this is per unit area. Remember this is per unit area. Always remember per unit area. Always remember Whenever somebody says density, you should use a word per unit area. So this is going to be area. For what density you want? What density you want? You want current density. You want current density means nothing but I. I by A. I by A. What are the units for currents are amperes per meter square. That's it. Amperes per meter square is the unit for the current density. Remember that. Remember that a unit per the current per unit area is nothing but current density. I by A. Current density is going to be I by A. Current density J is equal to I by A, and the units is going to be amperes per meter square. Amperes per meter square is going to be amperes per meter square. That is very important. See, now how do you calculate this? How do you express this in terms of many other values? In terms of drift velocity and other values, how will you express this? I will express this. I'll do one thing, sir. I'll do one thing. Let's consider. Let's consider. Let's consider a semiconductor bar of length L. A conductor bar of length L. That is going to be a length L. It's having a length L. Let's assume that you are going to have a length L, and then this is going to be area of cross section is going to be A. And let's say you have all these electrons here. All these electrons are here. All these electrons are here. And how many electrons are? Assume that you have n number of electrons. N number of electrons. N electrons are there. N electrons are there. N electrons are there, and having a length of L. Right now the electrons passing through any cross section area, the total number of electrons passing through any cross section area of a unit per unit time. In a unit time, let's consider this. So some area you consider here. Consider some area here. So how many number of electrons will be crossing, sir? So the number of electrons which are crossing per unit time, the number of electrons which are passing per unit time is going to be n by t, right? And each electron charge is how much, sir? Each electron will be having a charge of q. Each electron, so the current I, whenever there is just a flow of charge carriers, that electrons, so each electron has a charge per time t, and then how many number of electrons are there, sir? I. Sorry, n number of electrons are there. So understand this very clearly. Understand this very clearly, sir. Understand this very clearly, which is very important. Which is very important, right? So I is equal to nq by t. What is I? I is a current. Current is nothing but n is equal to number of electrons. The q is equal to charge of each electron. Charge of each electron, and the t is the time. The t is the time. Okay. Then I is equal to q by v. So I is equal to nq by nq by t. Nq by t. Sir, what we know? So the drift velocity. The drift velocity v. What we know? Drift velocity v. Drift velocity v is equal to. So how we calculate the velocity? The length by its time. How much length it is traveling by the time, right? So how will I t? Can I write t is equal to L by v? I'll write t is equal to L by v. T is equal to L by v. So then what you are going to get, sir? I will get I is equal to how much you will get, sir? I is equal to nq by L into v. That is nothing but nqv by L. nqv by L is going to be the current I. nqv by L is equal to nqv by L is a current, right? Now substitute this in the equation of J. What is J, sir? J, we have discussed that J is equal to I by A. So J is equal to nqv by L by A. So this is going to be J is equal to nqv by L into A. nqv by L into A. Right? Now what I'll do here is J is equal to, simply I'll write N, total number of electrons per unit volume. Total number of electrons per unit volume, N into L by A, N into L by A into Q into V, Q into V area. This is going to be Q into V. So this is going to be, I can write, this is going to J is equal to N Q V. N Q V is nothing but this, where, so this is a very important thing you should remember. J is equal to NQV, NQV, where N is equal to electron concentration, electron concentration, electron concentration. That is number of electrons per unit volume. Number of electrons per unit volume. Yes or no? Number of electrons per unit volume is nothing but electron concentration. Electron concentration. Right? So J is equal to NQV. Where, what is V, sir? What is V, sir, here? V is nothing but the drift velocity. The drift velocity. So NQV will give you current density J. Current density J is equal to NQV. Okay. So that is what a current density formula, which is very important formula. Obviously, no change in the units, amperes per meter square only. Amperes per meter square only. Right? So if electron, if you know the electron concentration, the charge of the electron, you will know only. What should you know, sir? You should know the drift velocity. Drift velocity is going to be V. So if you know the drift velocity V, then you can calculate the J. You can calculate the current density. Okay. Next we have something called conductivity, which is very important, sir. Many times questions were asked based on this formula. Many times the questions were asked based on this formula. Okay, based on this formula. So what we know, sir, we know that J is equal to, just now we have done N Q V. What is the V, sir? V is the drift velocity. Drift velocity V is equal to, just now we know that mobility into applied electric field. Mobility into applied electric field we know. Substitute here, sir. Simply it's going to be J is equal to N Q mu into E, epsilon or E, whatever you want. You can write E. Actually, generally we will write E. So J is equal to, now this N Q mu into E. NQ mu into E, and this J is equal to, generally we call it as sigma into E, where sigma is what? Where sigma is conductivity, where sigma is conductivity. Okay, what is that, sir? Sigma is equal to N Q mu. Okay, so what are the units for this, sir? This units of is going to be ohm meter inverse. Ohm meter inverse is going to be the units of the conductivity. Ohm meter inverse is the conductivity. So remember these two formulas, which are very important. Okay. Now, okay, we have a problem here. Look at the problem. Very interesting problem, sir. This is, find electric field at point B. Find electric field at midpoint. So he is asking us to calculate two values. He has given it. There is a uniform conduction bar of length 1 micrometer, a uniform bar of 1 micrometer length, a uniform conduction bar of 1 micrometer length, which is applied a voltage of 2 volts, which applied a voltage of 2 volts, right? Find the electric field at the point B and find the electric field at midpoint. Is asking us to choose two values, two areas. So here is asking first thing is asking here at the center, at the end of this x is equal to 1 meter. That is B. At B point is asking, and is also asking us to calculate at the center, at the center, at the center, at the center. Assume that is going to be a center. If V is not center, assume sir, what is there? Why are you so worried? So at the center is asking. So center means what will the value of x, sir? The total value of x is equal to how much, sir? Total value of x is how much, sir? Total value of x is equal to 1 micrometer. And then he is asking here now it's going to be 0.5 micrometers. 0.5 micrometers. At 0.5 micrometers he is asking. Sir, so what is asking, sir? He is asking us to calculate electric field. Electric field. Sir, now electric field E, this is very important. Electric field E at B, that is x is equal to 1 micrometer. X is equal to 1 micrometer point. X is equal to 1 micrometer point. So simply you should remember electric field E is equal to dV by dx. Electric field E is equal to, you know that is going to be dV by dx. dV by dx. So how much voltage difference it will be, sir? If you find out here, so here it will be having 0, and at this point it will be at voltage. What will the voltage, sir? Here you will be having 2 volts here. You will be having 2 volts here. So then what will you get, sir? You will get 0 minus 2 volts by dx. Distance, how much distance, sir, it is? It is going to be 0 and this is going to be 1 micrometer distance. This is going to be 1 micrometer. So 0 minus 0. Not just 1 micrometer, right? It's going to be 1 micrometer. 1 micrometer. So electric field E at point B is going to be 2 by 1 micrometer. So how much will get, sir? It's going to be 2 into 10 to the power of 6. 2 into 10 to the power of 6. What are the units for electric field, sir? Electric field units is going to be volts per meter. Volts per meter. This is going to be the solution for point A. This is going to be the solution for point A. Right? Then what will be the voltage at the midpoint? Now he's asking electric field at midpoint. Electric field at midpoint. At midpoint is asking. Today very less students are attended. Any issue, sir? Why many students are absent today? Only I can see only 2 or 3 people. Raviteja, Harika and Satish are listening only, I think. Why many people are not attending, sir? Any reason? Any reason, do you know? Any reason? No reason at all? No reason at all? Why very less number of students are coming, sir? Don't know? Okay, Satish. Okay, very good. At least you have come. At least you have come. That's good. So electric field V is again you should use the formula dV by dx. dV by dx. So at this point x is equal to 0 and at this point this is going to be 2 volts means. So what will the voltage across this point, sir? The voltage across this point is going to be obviously 1 volt. So this is going to be 0 minus 1 volt by 0 minus at the distance is going to be 0.5 micrometer. 0.5 micrometers. So what we'll get, sir? We'll get this is going to be again 1 by 0.5 into 10 to the power of 6 volts per meter. If you calculate it here, you will get 2 into 10 to the power of 6 volts per meter. You can see here both the answers are same. Both the answers are same. Both are going to be 2 into 10 to the power of 6 volts per meter. 2 into 10 to the power of 6 volts per meter is the answer which you got. So it means what you should remember here is the electric field is constant, uniform across the uniform conduction bar. That is why it says uniform conduction bar. So electric field is constant. Electric field is constant throughout the conduction band. So from 0 to 1 micrometer also you will be having 2 into 10 to the power of 6 volts per meter is electric field. The voltage may be changing. But remember the electric field will be constant. No change in the electric field. That will be constant. That's 2 into 10 to the power of 6 volts per meter. 2 into 10 to the power of 6 volts per meter is the value. 2 into 10 to the power of 6 volts per meter is going to be the value. This is what the question number 1. Right? Next question. Shall we do it? The next question, sir. We will solve another problem also. Yeah, we have another problem. Electrons in some conductor have a density of 10 to the power of 20 per centimeter cube. Remember the units are centimeters here. Okay. So electrons in some conductor have a density of 10 to the power of 20 per centimeter cube, and the mobility mu is equal to 500 centimeter square per volt second. If a uniform electric field of 1 volt per meter is applied, if a uniform electric field of 1 volt per meter is applied, find the conductivity sigma and current density J. Okay. So this is very easy, sir. Very easy. First you should know what is electrons in conductor. In some conductor, electron in some conductor have a density of. So what this represents, sir? What is this 10 to the power of 20 per centimeter cube? 10 to the power of 20 per centimeter cube. What it represents, sir? It represents the electron concentration N. Okay, this is electron concentration. First of all, understanding a problem itself is a big problem. If you understand the problem, there is no problem at all. Right? First the problem is going to be, if you should understand the problem itself. You should know what are the given values. The given value here is N. N is what is that? Electron concentration. If you know this electron concentration value, you can calculate whatever you want. So first of all, you should know what is given. What is given, sir? Electron concentration N is given. Electron concentration N is equal to 10 to the power 20 per centimeter cube. N is equal to 10 to the power 20 per centimeter cube. And then you will be having something called mu. You will be having something called mu, which is nothing but 500 centimeter square per volt second. And then he says here he has given an electric field of E. Electric field E is equal to how much, sir? He says 1 volt per meter. Sir, you should remember now here, as I told you, either you should convert this centimeter square into centimeter cube into meter cube, or this is centimeter, or you should convert this meters into centimeters. Ensure that while you are solving the problem, ensure that all the units are same. Okay, so all the units should be same, sir. There should not be any difference. So convert this. Anyway, these two are in centimeters. So convert this also into centimeters. If you convert them into centimeters, now what will get, sir? So 1 volt per meter. You will get 0.01 volt per centimeter, or you can write it as 10 to the power of minus 2 volts per centimeter is what you should write. So it is going to be 10 to the power of minus 2 volts per centimeter is what you should write. 10 to the power of minus 2 volts per centimeter you should write. So now what is asking, sir, is asking us to calculate conductivity sigma and the current density J. No problem, we will do that. These are directly formula based questions. These are directly formula based questions, which are fundamentals. That is the reason why I am discussing here. That is the reason why I am discussing here. That is the reason why I am discussing here. Okay. So what is conductivity sigma? Just now we have written, sir. What is the formula for conductivity? What is the formula for conductivity? Can somebody tell me what is the formula for conductivity? What is the formula for conductivity? Formula for conductivity is going to be electron concentration into each electron charge and into its mobility. Its mobility mu. Very simple. Its mobility mu. Okay. NQ mu. NQ mu is what the conductivity is. NQ means what the conductivity. What is answer concentration? I think it is given at 10 to the power of 20 into what is the charge of an electron? What charge of an electron? Correct, Satish. You are right. Satish, you are right. NQ mu, right? It's going to be 10 to the power of 20 into 1.60 into 10 to the power of minus 19. Charge of electron is by default. You should remember. By default, you should remember the charge of electron. By default you should remember. Okay. Otherwise, it will give you in the question. If it gives in the question, you should take the as it is. And if it is not giving, then you should remember the value of charge of electron is going to 1.6 in 10 to the power of minus 19 coulombs. Then what is the mu, sir? Mu is going to be 500. Yes or no? Mobility is given as 500 centimeter square per volt second. Centimeter square per volt second. Centimeter square per volt second. Okay, now calculate them, sir. Very simply, I think you will get it as this is 10 to the power of 20. This is 10 to the power of minus 19. I think you will get here is 10 into 1.6 into 500. This will be 16 into 500. 16 5 is 80. 0 0. That's what you will get it right, yes or no? Okay. So what are the units for this, sir? What are the units for this? Generally, it's going to be ohm centimeter inverse, or you can write ohm centimeters. Okay. So this is what is given. This is what is given. Did you get the value? Did you get any other value? Correct, Harika, you are right. Harika, you are right. Harika, you are right. Harika, you are right. Similarly, shall we calculate this J value, sir? What is the formula for J? J is simply, you should know, J is simply sigma into E. Sigma into E. Sigma into E. Okay. So how to calculate this? Simply substitute all the values. J is equal to, just now we got is going to be 8,000 into, is going to be, this also we are converted into centimeters. Do you remember? We have just, because of that, we have converted this into centimeters. Which is 10 to the power of minus 2 volts per centimeter. 10 to the power of minus 2 volts per centimeter is what it is given. So if you do it now, what will get, sir? J is equal to now. J is equal to, so this is going to be 10 to 80 amperes per centimeter square. 80 amperes per centimeter square is what we'll get. So this is sigma value and this is going to be J value. That is going to be sigma and this is going to be J value. This is going to be sigma and then this is going to be J. So sigma is going to be 8,000. 8,000. Okay. So these are the two values which is expected. These are the two values which is expected. These are the two values which is expected. Okay. This is what he is expecting. But you should remember the units, sir. Units are very must, sir, for the conductivity and then the current density. As I told, current density is simply amperes per centimeter square. If you remember the logic, what I told you, density means area. Current is nothing but amperes per centimeter square is what the answer is going to be that. Okay, next. Next, here comes the another important concept, something called bonding forces in solids. So you might have heard all these two bondings. That generally there will be two bondings. So what are the two bondings, sir? What are the two bondings? Can somebody comment? What are the two bonds which you know? What are the two bonds which you know? Bonding force in solids. You might have studied these two bondings earlier also. What are they? You will be having two types of bonding forces. One is called ionic bond, second one is called covalent bond. Ionic bond and covalent bond. Ionic bond and covalent bond. So the name itself indicates. So remember. So what is the ionic bond? What is ionic bond? Covalent and ionic. Correct, Satish, you are right. Satish, you are right. Covalent and ionic bond. So we will be having ionic bond and covalent bond. We will be having ionic bond and covalent bond. So what do you mean by ionic bond? It forms between two oppositely charged ions. Two oppositely charged ions which are produced by the transfer of electrons from one atom to other. Which are produced by the transfer of electrons from one atom to other atom. Right? So example, can tell me example is going to be NaCl. It's going to be NaCl. NaCl. Sodium chloride. Sodium chloride. Sodium chloride. So how will you get, sir? This bond is formed because of Na plus and then Cl minus. Cl minus. This is positive ion. This is positive ion. And then this is negative ion. This is negative ion. Can somebody tell me why this ion has become positive and why this ion has become negative? Why these two ions are formed? Why positive ion and negative ions are formed? There is a beautiful reason behind it. Right? There is a beautiful reason behind it. Na plus and Cl minus. The bond which is existing between the Na plus ion and the Cl minus ion. Cl minus ion. That is called sodium chloride. The salt generally which we call. The salt generally which we call is nothing but ionic bond. Right? Can somebody tell me why Na is called Na plus and Cl is called Cl minus? How a Na has become Na plus and Cl has become Cl minus? Right? So why a positive ion? What do you mean by a positive ion? What do you mean by negative ion? In detail. Think it today and tell me tomorrow. To gain octet configuration, what will happen? What will happen, Raviteja? To gain octet configuration, what Na plus will do, what Na will do and Cl will do. What Na will do and Cl will do, sir? Here Na donates or accepts electron. Na donates or accepts an electron. Tell me. Sodium, whether sodium donates or accepts electron. Sodium. Okay, I'll tell you. Sodium donates an electron and becomes a positive ion. Donates, yes, Satish, you are right. Satish, you are right. Sodium donates an electron and chlorine accepts an electron and becomes minus ion. I'll tell you in detail why Na is called Na plus and Cl called Cl minus in tomorrow's. Yes, sodium loses one electron and chlorine gains one electron. But why this is Na plus and Na minus? Why? What did this indicates? Na plus and Cl minus. What this Na plus and Cl minus indicates? That I will explain in tomorrow's class. That I will explain in detail tomorrow's class. Very, very important, sir. You should understand why Na is written as Na plus and Cl is written as Cl minus. That I will discuss in tomorrow's class. Don't worry. Meanwhile, you just think about it. And we have something called covalent bond. What do you mean by covalent bond? It is formed by sharing electrons between neighboring atoms. So simply it is nothing but covalent. Cooperation between valency atoms, valency electrons. The bond which is formed, the bond which is formed because of the cooperation of the valency electrons is called covalent bond. Covalent. Generally, what will happen, sir? When you do something, cooperation means what? Cooperation means both of them will come together, share their points, and they'll work together. That is cooperation. Generally, we use the word he is not cooperating. What do you mean by he is not cooperating? Means you are putting your efforts, but he is not putting his efforts or her efforts. Okay, this is very important. Okay, that is covalent bond. In case of a covalent bond, what happens, sir? There will be sharing of electrons. There will be sharing of electrons by the neighboring atoms. A graphical representation we'll discuss in tomorrow's class. A graphical representation of both ionic bond and covalent bond we'll try to discuss in tomorrow's class. And tomorrow we'll also discuss about, very importantly, what do you mean by an electron and hole, how they are formed and everything. Right? Tomorrow we'll try to focus on that point also. Okay. So what do you mean by electrons and holes? So 3 points I should discuss tomorrow in the beginning. So before I start, I have to discuss why Na has become Na positive ion and Cl has become Cl minus ion. That I have to discuss, and how this covalent bond looks like, three-dimensional or two-dimensional view of covalent bond I should discuss. Three-dimensional view of the covalent bond I should also discuss. Okay. These are the 2 things which I should definitely discuss, and then I'll keep on moving to electrons and holes. Then we'll discuss in detail about what is intrinsic semiconductor, what is extrinsic semiconductor, how they are formed. Also we'll discuss. So in tomorrow's class, we'll continue our discussion on intrinsic and extrinsic semiconductor. Slowly we are getting into the subject now. Okay, very detailed we'll discuss in tomorrow's class. Okay. Yeah. We have something called a plus subscription. The plus subscription is nothing but you can attend all the live classes. You can attend all the crash courses. You can write the weekly tests, which are very, very important weekly tests you should write. And you will be having something called doubt solving sessions. Every 4th hour is going to be a doubt solving session. You can listen to the classes in English and Hindi. Those who don't understand English, they can listen in Hindi also. And you will be having something called rank improvement batch also. So there are the benefits of plus subscription. Then you will be having iconic subscription. So what do you mean by iconic subscription is you will be having a personal coach. You will be given a study planner. You will be given study board sessions, and a personal test analysis will be conducted, and prepared study material will also be given. And for 12 months plus subscription is 27,225 rupees. 18 months plus subscription is 34,650 rupees. 24 months plus subscription is going to be 39,600 rupees. Iconic subscription for 12 months is going to be 45,225 rupees. Iconic subscription for 24 months is going to be 66,600 rupees. 66,600 rupees after using the code SVS10. So don't forget to use the code SVS10, which will give you 10% discount. And all my class notes will be available on Unacademy GATE English or Telegram channel. Please download the Telegram channel notes, right? Immediately after the class, you can download the notes, right? So I'm teaching on Unacademy GATE English. Along with that, we have a Creatrix GATE and Unacademy GATE Mechanical Engineering, Unacademy Civil Engineering and Chemical Engineering, Unacademy Computer Science, Unacademy GATE questions, separate GATE questions class is there. And then, Harika, tell me why carbon is not a semiconductor? Yes. Sorry, I forgot to ask the question. Do you have the answer for that? Why carbon is not a semiconductor? Thank you for reminding me. Why carbon is not a semiconductor? If you have an answer, let me know. Otherwise, we'll discuss in tomorrow's class. Why carbon is not a semiconductor? It has a large band gap. Okay, that is one good reason actually. Yeah. That's a good reason actually. Yeah, we'll discuss this point also in tomorrow's discussion. Very good, Harika. Very good, Harika. Thank you for reminding me. We'll discuss this point in tomorrow's class, definitely. Okay. And thank you. Please like the session, share the session, subscribe for the channel, and hit the bell icon. Hit the bell icon. Hit the bell icon. Hit the bell icon. Thank you. Thank you all. Thank you. We'll catch up in tomorrow's